Hello everyone. So let's start this session. What we are going to do in today's session, we are going to talk about quantitative aptitude 2025, and today's topic is going to be number system. And in number system, what we are supposed to do, we are going to talk about remainders and cyclicity. Okay, so we are going to talk about couple of concepts of remainder. So in remainder, there is one important concept, that is uh, negative remainder, right? So what is so before we proceed, so basically you see there is a session that is reached to 99 and it is a must attend session. So basically it is going to be conducted for 2 whole days, that is on 2nd August and 3rd August. So it is from 10 to 5, and that is definitely going to help you improve your score by at least 6 to 7 or maybe 10 questions, depends where you are standing today. So now let's start. So basically, if we are going to talk about the concept, so the most important concept in this is going to be negative remainder, right? So basically, what is negative remainder? And I'm going to also talk about a couple of I wouldn't say formula, the couple of theorems that is going to help you find remainders very soon. So the first concept is A is equal to dq plus r. So this is the basic equation of remainders. So what is A? A is dividend, the number that is going to be divided. D is divisor, the number that is going to divide the number, right? Q is quotient, the value that you are going to get after the division. Then R stands for remainder. So remainder means what is left out, right? So the first and most important thing in remainders is, for example, if numbers are added. So for example, if I say A is being divided by D and remainder is R1, and B, another number, is being divided by D, remainder is R2. So if A plus B is being divided by D, remainder is going to be R1 plus R2. So if numbers are added, remainders are also added. If numbers are multiplied, so A plus A into B is being divided by D, the remainder is going to be R1 into R2. So if numbers are added, remainders are also added. If numbers are multiplied, remainders are also multiplied. So basically, this is the basic concept of remainders. Now, what is negative remainder? So for example, if I say I'm dividing 8 by 3, so what is the remainder I'm going to get? So if you are doing 8 by 3, remainder comes out to be 2, right? Because 2 is left out. Now, a remainder is defined as a number that what is left out after division, right? Now, negative remainder is a number what should be added so it will be divided. So if I divide 1 to 8, that will be divisible by 3. So 8 divided by 3 will also be giving me a remainder of -1. So always remember this, that I can write it like this. So 8 is equal to 3 into 2 plus 2. So basically 8 is the dividend, 3 is the divisor, 2 is the quotient, remainder is 2. That is one way to write it. Second way to write is 3 into 3 into 3 into 3 minus 1. So 3 is the divisor, 3 is the quotient, and -1 is the remainder. So remainder can be 2 or it can be -1. Both ways it works and both are fine. Any of them is wrong? No, both of them are right. So but your final answer can never be in terms of negative remainder. Your final answer will always be in terms of positive remainder. So always remember this. Now there is one theorem that is called Fermat's theorem in remainder. So Fermat's theorem says that n power p divided by n power p minus 1 divided by p, remainder is 1. That is always true. So remainder, when you are dividing n by p minus 1, remainder is always 1. So, and given that n shouldn't be a multiple of p. So for example, if I'm taking an example that let's say um, uh, what we can take an example of 3. 3 is a number. I'm dividing by 7. 7 is a prime number, right? So 3 power 6 divided by 7, remainder is going to be 1. Now that is Fermat's theorem. So P is here, P, it must be a prime number. You can pick another prime number. For example, 6 power 10 divided by 11 will give you a remainder of 1. So basically that is the Fermat's theorem, and we can get remainders directly by using this. Okay, so now let's see some questions and see what kind of approaches we can take. So now these questions. So remainder when 2 power 29 power 29 power 29 is divided by 9, what is the remainder? That's the question, right? So what approach that we should take? So first of all, 29 into 29 is going to give us 29 power 729. So basically, what is the question? The question says 29 into 29 into 29. It is written 729 times, and it is being divided by what? 9. So 29 divided by 9, remainder is what? 2. 29 divided by 9, remainder is what? 2. So basically, if numbers are being multiplied, remainders will also be multiplied. And how many times I'm going to get to? That is going to be 729 times. Okay. Sorry, 29 into 29 is not 729, it is 841. That's my bad. So that is 841. So it is going to be what? 841. Okay. Now, 2 power 1 divided by 9 going to give me a remainder of 2. 2 square divided by 9, so means 4 divided by 9 is going to give me a remainder of 4. Okay, 2 cube, that is 8. 8 divided by 9 is going to give me a remainder of minus 1. So you can either say that remainder is 8, or you can say remainder is minus 1. So 2 power 3 into 2 power 3 is going to give me a remainder of minus 1 into minus 1, that is going to be plus 1. So 2 power 6 is going to give me a remainder of 1. Okay. Now what remainder we got? 2 power 841. So what we can say, that is 2 power 6 into 2 power 6 into 2 power 6 and so on. It is, I'm going to get 140 times into 2. Right. So basically this becomes 2 power 6 power 140. Harsh, I'll come to that query. Don't worry about it. So basically this becomes 2 power 6 power 140 into 2. Now in each case, I'm going to get a remainder of 1. So 1 into 1 into 1 into 2. So overall remainder comes out to be 2, and that's how we can calculate. That's how we can get the answer of these kind of questions. So make a pattern until unless you get a remainder of 1, and you can get the answer directly. So whenever you are going to see these kind of questions, always write down the pattern, and getting the answer will never be a tough task. Remainders questions are generally very straightforward. So don't worry about it. You are definitely going to get the answers quickly. So now this question says, in a division problem, product of quotient and remainder is 24. Okay. So basically what we have, so let's say the number is n, it is being divided by d, remainder is, quotient is q, remainder is r. Okay. Now it says that quotient and remainder, so q into r is equal to 24. Okay. And their sum is q plus r is equal to what? Q into r is what? 10. Okay. So two numbers are adding up to 10, and two numbers that are going to have a product of 24. So what can be two possible numbers? So if you say unit digit is 4 and unit digit is 0, so you can have 5 plus 5, you can have 6 plus 4. So 6 plus 4 is 10, and 6 into 4 is 24. So I know either quotient is 6, remainder is 4, or, so Q and R, there are two possibilities. One possibility is going to be quotient is 6, remainder is 4. Second possibility is quotient is 4, remainder is 6. Now, there are two possibilities. Okay. Now, question says that if the divisor is 5, so it means D is 5. So if you are dividing a number by 5, your remainder must be less than 5. It means your remainder cannot be 6. It means what should be the remainder? That is going to be 4. So number is going to be 5 into 6 plus 4. That is going to be 34. So answer of this question is going to be 34, and that's how we can calculate. Always remember that your remainder is always going to be less than your divisor. Then only it is going to be true. If your remainder is greater than the divisor, then divide it further and keep on dividing it unless you get your remainder that is less than divisor. That's the most important thing. Okay. So I hope everyone is clear with question number 2. Now let's start this question. What does it say? Question number 3. So if anyone has any doubt or you are confused at any point, then kindly do ask. So now this question says that 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial up to 95 factorial, and it is being divided by 15. What is the remainder? So I'm going to write 1 factorial is 1. 2 factorial is 2 into 1, that is 2. 3 factorial is 3 into 2 into 1, that is 6. 4 factorial is 24. 5 factorial is 120. 6 factorial is 6 into 5 factorial, that is 120, and so on. Now I want to divide this number by 15. So 1 divided by 15, remainder is 1. 2 divided by 15, remainder is 2. 6 divided by 15, remainder is 6. 24 divided by 15, remainder is 24. 120 divided by 15, remainder is 0. Very nice, Harsh. Then after that, remainders are always going to be 0. So what is the overall remainder we are getting? That is 24 plus 6, 30. 30 plus 3 is 33. So overall remainder comes out to be 33. But 33 is greater than 15. So I need to further divide 33 by 15. And in that case, my remainder comes out to be 3. So answer of this question is going to be 3. And that's how we can get the answer easily. So always remember, if numbers are added, remainders will also be added. If numbers are multiplied, remainders will also be multiplied. Okay, let's move on to the next one. I need to find out what is the unit digit of this. Okay, so how do we calculate unit digit? So to calculate unit digit, the basic concept is if a number ends with 0, 1, 5 or 6, its unit digit always stays same. They are going to be 0, 1, 5 or 6 only, irrespective of power. Obviously, there is a condition that power should be a natural number. Now, in other case, for example, 2, 3, 4, 7, 8, 9. So basically, generally people go with the cyclicity thing. I'm not going to talk about cyclicity, that what is the cyclicity. So the standard cyclicity is 4, right? So divide power by 4. So and when we calculate unit digit, the tens place and hundreds place doesn't make a difference. So just remove these. So whenever you see a question of cyclicity, always cancel out the unit digit and tens place because these are not important. So your question is effectively 3 power 85 minus 5 power 37 plus 7 power 96. The standard cyclicity number is 4. So divide the power by cyclicity. So divide 85 by 4. What is the remainder? Remainder is 1, right? Now base power remainder. So 3 power 1. This is 5 power 37. Unit digit is going to be 5 only. Now divide 96 by 4. Remainder is what? Remainder is 0, right? So if remainder is 0, then base power 4. So 7 power 4. Okay. So I got 3 minus 5. 7 power 4 comes out to be 2401. So unit digit comes out to be 1. So this becomes 4 minus 5, right? But if you see this number and this number, both the numbers are greater than this number. So this is the unit digit. But before that, there is going to be other digits as well. Before 5, there is going to be other digits as well. So basically, this number effectively becomes 14 minus 5. So unit digit of this comes out to be 9. So answer of this question is going to be option A, that is 9. I hope everyone is clear with this. Don't go with that thing that unit digit cyclicity of 2 is 3, 2 is 4, cyclicity of 3 is 4, cyclicity of 7 is 4, 8 is 4, for 4 and 9 cyclicity is 2. Don't worry about it. Just go with the general number that cyclicity of every digit is 4 and you are good to go. You don't have to remember the cyclicity of each digit. Make sense? Now this one. Unit digit of p cube is 4. What are the possible unit digits of p plus 3 whole cube? Okay. So unit digit of p cube is 4. It means p has to be even number. So if p has to be even number, so unit digit of p is going to be 2, 4, 6, and 8. 0 not possible. So let's say 0. 0 power 3 is 0. 2 power 3 is 8. 4 power 3 unit digit is 4. 6 power 3 unit digit is 6. 8 power 3 unit digit is 2. It means I can directly say that unit digit of p is what? Unit digit of p is 4. Right? Now, unit digit of p plus 3. So unit digit of p plus 3 is going to be 7. 7 cube. So what is the unit digit of 7 cube? That's going to be 3. That's option B. We can easily get the answer of these kind of questions. So ज्यादा कुछ करने की जरूरत नहीं है, सीधे सीधे अपना देख लो कि यूनिट डिजिट, अगर यूनिट डिजिट 4 है, राइट, सो इसका मतलब नंबर ऑड तो नहीं हो सकता, क्योंकि ऑड नंबर की कोई भी यूनिट डिजिट होगी वो हमेशा ऑड होगी, राइट. सो डिजिट्स जो पी की यूनिट डिजिट हो सकती है वो इवन हो सकती है. तो इवन में क्या हो सकता है? 0, 2, 4, 6, 8. 0 हो नहीं सकता, 6 हो नहीं सकता, 2 हो नहीं सकता, 8 हो नहीं सकता, तो बचा क्या? 4. मैंने सबकी पावर 3 की यूनिट डिजिट निकाल के देख ली. ठीक है. So understood what is the approach of these kind of questions? Now let's move on to this one. Now can someone answer me this question? What should be the answer of this question? What is the unit digit of this? What is the answer of this question? So divide power by 3. So divide 95 by 3. What is the divide power by 4. Get the remainder. So divide 95 by 4. What is the remainder? 3. So this becomes 7 power 3 minus divide power by 4. So 58 by 4. What is the remainder? 2. So 3 power 2. So 7 power 3 unit digit is going to be 3. 7 cube is 343. 3 square unit digit is 9. So anyhow before 3 we are going to have some part. Before 9 we are going to have some. So when I am going to subtract this from this, what should be the unit digit? That should be 4. So answer of this question is going to be option B. It is going to be fairly easy question. So always remember, when you need to calculate unit digit, just divide power by 4 and get the remainder, then base power remainder. I hope everyone is clear with this. Now let's look at this question. What does it say? So what is the remainder when 2 power 97 is divided by 97? So I need remainder when 2 power 97 divided by 97. In today's session itself, I told that n power p minus 1 divided by p gives you a remainder 1. N power p plus 1 divided by p gives you a remainder 1. That is Fermat's theorem, right? 97 is a prime number, yes. So 97 minus 1 is 96. So 2 power 96 divided by 97 is going to give you a remainder of what? Remainder of 1. So 2 power 97 can be written as 2 power 96 into 2. This divided by 97. So 2 power 96 divided by 97, remainder is what? 1. 2 power 1 divided by 97, remainder is what? 2. So what is the overall remainder we are going to get? That is going to be 2. That's option A. Easily we can get the answer of this question. Do we have to do much about it? No. Simple. Fermat's theorem is going to give you the answer of this question directly. Don't have to spend a lot of time. Just look at the divisor. If divisor is prime, you are getting the answer quickly. If divisor is not prime, you can still make a pattern. You can still get the answer. In this case, I think making a pattern is going to be a tough task. Now, let's see this question. What does it say? When a number is divided by 4, remainder is 2. When a number is divided by 4, remainder is 2. When quotient is divided by 2, remainder is 1. So let's say n. N is being divided by what? 4. Quotient, I'm getting something. What is the remainder? 2. Now question says when quotient means q is divided by 2, that is going to be 1. Now what is the remainder when number is being divided by 8? Okay, I'm just going to place this value of q over here. So what I'm going to get? I'm going to get n is equal to 4 times 2q1 plus 1 plus 2. So I am going to get 8q1 plus 4 plus 2, that is 6. So the number, if the number is being divided by 8, what is the remainder we are going to get? 6. So what should be the answer of this question? That's going to be option C, that is going to be 6. So these kind of questions can be dealt in this way. So I hope everyone is clear. Now we have your next session on 27th July, Sunday, 8:30. In that session, algebra is going to be covered, and All India CDC mock is going to be from 8 to 11. And if you want to write CAT on the center, you can also book it at the for the center. So from your portal itself, right? So you can also choose your preferred city, preferred slot, and you are going, definitely it is going to be cat-like experience. Thank you. Now, if there is any doubt, do let me know. So now, anyone has any doubt? Okay. Then let me wind up the session. Take care. Bye bye. Good night.